We've learned a bunch of concepts so far. Now it's time to apply them in practice. Here are some programming problems that will help you get a feel for the Python programming language. It will help you sharpen your programming logic. Now, the way we'll approach these programming problems is that first off, I'll give you the statement, the problem statement. This problem statement will explain what is it that you have to program. Then my suggestion is you try the programming task by yourself. If you can't understand how to get started, next look at the hint. The hint will give you some idea of how to approach the problem. Once again, see if you can solve the problem by yourself. Really, this is the only way to learn. And finally, we'll actually show you the solution for this programming problem step by step with explanations. Make sure that you actually understand what is going on. Run the code, make changes to the code, and see how that affects the solution. All right, we are now ready to get started. We'll start off with a very simple program. We want to add two numbers. These numbers we want to accept as input from the user. So don't hard code those numbers into variables in your code. Here is a hint for you to get started. Remember that when you accept input from the user, the input is usually in a string format. We want to add two numbers, which means that the user input will need to be converted to some kind of number format, either integers or floats, before you can perform addition. The first step in the solution is to actually accept user input. We need two different bits of input from the user for the two numbers that we have to add together. Whenever you accept user input, it's good practice to write out a friendly message which prompts the user for the input that he has to provide. The input function that we use to accept user input returns the input in string format. This has to be converted to some kind of number format. We are going to convert the user input to floating point numbers. We then store the user input in the variables a and b. And once we have this information, adding these two numbers and printing them to screen is very straightforward. We store the result of the addition in the s variable and print the sum s to screen using the print function. There's no error checking that we've actually added to the code here because we haven't studied it yet. We haven't learned how we can check whether the number is an integer or not, and how we can handle situations where the input is not a number. We can execute this bit of code. The first number we enter is 4, we then enter 5, and we get the sum 4 plus 5 is equal to 9. We are now ready to try out the next program. Here is the problem statement. We want to accept an integer as the input from the user. Once again, no error checking required. And we want to print our name as many times as the user has specified. So if the user enters 5, we want to print out our name 5 times. And here is the hint if you need it. Now, once you know that an action has to be performed a certain number of times, your mind should immediately go to loops. Now, we have two kinds of loops, either for loops or while loops. If you know the number of times the loop has to be iterated through or the action has to be performed, then for loops are much simpler, and that's your loop of choice. We accept user input as usual. Remember, the input is in the form of a string. It has to be converted to an integer. We'll set up a for loop for I in range num. The range function is extremely useful to iterate num times, and we print out our name. Execute this cell. We enter 4 as the number of times we want our name printed, and our program does exactly that. Here is another problem for you to try. We want to implement the same code that we wrote earlier. We want to accept user input and print our name that many times. But this time, let's do it using a while loop rather than a for loop. Slightly more challenging. And here is the hint to help you get this program correct. Remember that when you use a while loop, you have to initialize your own counters and increment them yourself. When you're setting up the conditional expression, make sure that within the while loop, you change the counter value so that you don't get into an infinite loop situation. Here is where we accept the user input, which we convert to an integer. Here is our while loop, which runs so long as the value of our counter is less than the number. It's really important here to first initialize the counter value to 0 so that it starts at the right number. Do not use counters directly within the while loop. Otherwise, when Python first encounters it, it will be like it has never seen this variable before. Python will throw a name error indicating that the variable has not been defined. So long as our counter value is less than the number that the user input, we print our names. Make sure you increment the counter within the while loop. And notice how we use the plus equal to increment the counter. Run this code and you'll see that it executes just fine. Our name has been printed 5 times. I've just spoken about how important it is to initialize the counter correctly. Now let's implement the same code as before, but this time we'll initialize our counter to the value 1 instead of 0. So we accept a number from the user, we want to print out our name, but our counter has been initialized to 1. In order to have our program work correctly, we need to change the conditional expression of the while loop. So we need to execute the while loop so long as our counter is less than and equal to number. Notice the less than equal to. Let's say we want to print our name 6 times. If we start at 1, we get 6. Only if we go from 1 through 6, even when our counter is 6, we need the loop to execute once, which is why our conditional expression has changed. Here is the next problem statement. We accept a number as input from the user and we want to print out the multiplication table for that number. Let's say the user input 5. We want to print out 1 multiplied by 5 is equal to 5, 2 multiplied by 5 is equal to 10, and so on. And here is a hint that you can use to write this program. You can use a for loop to generate the multipliers. So you already have the user input number. To multiply it by 1, 2, 3, all the way up to 10, you can use the for loop to generate the range of numbers from 1 to 10. Here is the user input that we've stored in the variable num. We've assumed that the user is going to input an integer. There's no reason for this assumption. You can assume that the user is going to input a floating point number as well. All you have to do now is to set up a for loop where you have a variable which goes from 1 to 10. This we do using the range 1 to 11 function. In the range function, you have to specify the starting index, otherwise it will default to 0, and the ending index is not included in the range. So 11 is not included. So this goes from 1 to 10. And the print statement simply prints out the multiplication table in a nice format. So we say I multiplied by number is equal to the result, which is I multiplied by number. In this demo here, I want to see the 7 times table because that's kind of hard. And there you see it neatly printed on screen. Let's continue with our programming practice. This time we want to find the length of a list without using the built-in len operator. So far, we've been relying on len to find the lengths of many things. We want to do it ourselves in this program. If you're not able to get started with this problem, here is a hint that will help you get thinking. We can use a loop to iterate over the list. We've seen several examples of this. While iterating over a list, all you need to do is to have a counter which tracks how many items you've seen so far. Once you've broken things down in this manner, this program is very straightforward. Here is a list that we'll use for our example, just a list of numbers. The actual program is just 3 or 4 lines of code. We'll initialize a counter to 0. We'll iterate over all elements in the list using the for in statement. And for every element, we'll increment our counter by 1. And finally, when we've come to the last element of the list, our counter will hold the number of items that we counted, which is 9 in our case. Our next problem also involves the use of lists. We want to find the largest element, the maximum within a list of numbers without using the built-in max function. Here is a hint that will help you solve this problem. You can start off with an assumption that the first element in the list is the largest element. You'll store that somewhere in some variable. You'll then iterate over the list to check whether there is any element that is larger than this first element. If you find an element that's larger, you'll save the value of that element, and that becomes the element that you compare the rest of your list with. Once you have this logic sorted in your head, actually implementing this code is very straightforward. Let's store the first element of the list in the maximum variable. We'll assume that that's the largest element for now. We'll use the for in loop to iterate over all elements in the list. Let's take an example list to see how this program works. Let's assume that this is the list that you see on screen. The first element in this list is the number 10. Our variable maximum holds the number 10 when we enter the for loop. The first element in the list is the number 10 itself. 10 is not greater than 10. So we continue to the next element in the list, which is the number 1. 1 is not greater than 10. We move on to the element after that, which is 2. 2 is not greater than 10. So far, 10 is still our maximum. The next element in our list is the element 45. 45 is greater than our current maximum, which is 10, which means now we have a new maximum. Maximum will be equal to 45. 45 is indeed the largest element we've seen so far. We are on the right track. We go on to the last element in the list, which is 22. 22 is not greater than 45. Maximum continues to remain 45. The list that we used in our demo was much longer, which is why I didn't use that as an example. The largest element in our list here is the number 9, and that's what you see printed on screen. Just like we found the maximum element in the list, finding the minimum element in the list is exactly the same program, except for one tiny little change. We assume that the first element is the minimum. We perform the comparisons as we did before, but the comparison in our if statement will be, is the current element smaller than the current minimum that we have so far? And following the same series of steps that we saw when we calculated the maximum value in a list, we get the minimum value, and that's what is printed to screen. In this next problem statement, we're once again working with lists. Here, the problem is we want to find the average of all numbers in a list without using the built-in sum function. Here is the hint that will help you solve this problem. We want to find the average of numbers in the list. If you remember the formula for average, the average of any set of numbers is the sum of all the numbers divided by the count of how many numbers there are. In the same for loop where you iterate over all the items of the list, you can have one variable hold the running total, which will calculate the sum of all the numbers, another variable, which is the counter, which will count the items as you see them. And here is the code. We have two variables that we've initialized to 0. Count is equal to 0, total is equal to 0. We'll use the for in loop to iterate over all elements in the list. For every iteration, we'll increment the value of count by 1. We've seen one more element. And for every iteration, we'll add the value of that element to our total. We use the plus equal to in both cases to perform the plus operation. At the end of this for loop, when we exit, we'll have two values, the total and the count of items. We can simply divide the total by the count to get the average. And the average of all the 9 items in our list is 4.667. Let's confirm that this is indeed the case using the built-in functions. Sum of list divided by len of list gives us the same answer. Clearly, our program was correct. Here is the next programming problem. We'll move away from lists for a bit. We want to accept user input. The user gives us an integer. We want to find whether this integer is divisible by 5, is it divisible by 7, or both. Under all of these circumstances, we want to print out the right message to screen. Now, given the kind of checks that we want to make, the order of the if checks in our code actually matter. To ensure that the right message is printed to screen, make sure that you perform the if checks in the right order. In order to drive home the significance of the order in which you perform the conditional checks, the first solution to this problem will not be entirely correct. See whether you can spot the subtle error. We first accept the integer input from the user. Remember that the input function returns the input in the form of a string. We need to convert it to an integer, which we'll do using the int function. This is stored in the num variable. We'll first check to see whether this number is divisible by 5. We can do this using the modulo operator, which we've encountered before. If num modulo 5 is equal to 0, that is the remainder of dividing this number by 5 is equal to 0, then we can print out the number is divisible by 5. The print function in this example uses a syntax which you may not have encountered before. The number %s is divided by 5. %s is a placeholder where you'll feed in what you want displayed. In our case, we want the number displayed, and that's what we pass in. This is a string formatting operation. We simply use %s for the various placeholders within our string, and we feed in variables which we want fed into those placeholders. The formatting string, which will show the string as it will be displayed on the screen, is specified in quotes. Within the string, we have placeholders such as %s for a string value, %d for a number, and so on. After the quotes, we have another %sign, after which follow the variables which will feed in the value to those placeholders. This is very similar to C style formatting. We'll continue with our example now. If the number is not divisible by 5, we'll then check whether the number is divisible by 7, once again using the modulo operator. If it is, we'll print out the appropriate message to screen. We have another check to make. We check whether the number is divisible by 5 and by 7, and we'll print out the message the number is divisible by both 5 and 7. Now, what do you think is wrong with the program that you see on screen here? If you're not able to tell upfront why this program isn't entirely correct, one way for you to debug would be to execute this and see what's going on. In order to test this out, I'm going to enter the number 35, which is divisible by both 5 and 7. But the result I get is the number 35 is divisible by 5, not what I was expecting. The issue here lies in the order in which we've performed our if-else checks. We first need to check whether a number is divisible by both 5 and 7, and then we perform the individual checks for divisibility by 5 and divisibility by 7. Only then will we get the right results. Let's rewrite this code and fix the issues that we had. We'll take a number as input from the user. We'll first perform the check to see whether the number is divisible by both 5 and 7 and print out the appropriate message. The next check can be to see whether the number is divisible by either 7 or 5. We're first checking for divisibility by 7, and then we perform the checks for divisibility by 5. Now, if you execute this program, you'll find that it works correctly. Let's enter an integer that is only divisible by 7, for example, 21. I leave it to you to perform the checks for the numbers 35 and maybe 15 or 10, a number that is divisible by both 5 and 7, and a number that's only divisible by 5. For a slight change of pace, this problem will focus on strings. We want to count the number of times the letter E appears in a sentence. This is a sentence that you can take as a user input. Here is a hint that will help make the problem easier. We've spoken earlier of the fact that strings are essentially a list of characters. You can iterate over individual characters of a string using a for in loop in Python. But for every character, check to see whether that letter is an E. If it is, you will increment a counter. That's all there is. We can use the input built-in function in order to accept user input. This will be in the form of a string. We then initialize a counter to 0. This is our counter which will count the letter E. We then use a for loop to iterate over every character. For each character in the sentence, if the character is equal to E, simply increment our counter. Once we exit from the for loop, we can print the total number of E's that we encountered. Here is our sentence. I've entered 3 E's, and here is our count of E's. Here is a problem that involves the use of a dictionary. We have the math scores for a number of different students stored in this dictionary. We want to print the names of all those students who scored over 90 in math. Here is the hint that you can use to solve this problem. All the math scores for students are present in a dictionary. You already know how to iterate over all keys in a dictionary and look up the corresponding values. Just use an if check to check whether the math scores are above 90 and then just print out the name of the student. We'll first initialize a dictionary of math scores. Here we see that the students Judy, Athira, and Anu have scored over 90. These are the names that we want printed to screen. We've seen that there are several ways to iterate over the dictionary. You can iterate over the keys or only the values. In this particular problem statement, we want to access the key as well as the value, which is why we'll iterate over the dictionary items. The items are tuples of key value pairs, and using this tuple, we'll extract the name and the corresponding score for every student. If this particular student has scored over 90, we'll simply print out the student's name. And when you execute this bit of code, you should get the right result. Judy, Athara, and Anu have scored over 90. Here is another problem statement that uses the same dictionary. We want to look at all the math scores for our student, and if we find that a student has scored between 50 and 60, we want to give them some grace marks. We want to increment their scores by 10. The only hint that I'm going to give you here is that this is very similar to the last problem, except that our conditional checks have changed somewhat. The other difference is that we actually want to edit a value present in the dictionary. And here is the problem solution. We iterate over the name and the score for every student present in our dictionary. We iterate over it in tuple form. We then perform a simple if check to see if the score is within the range 50 to 60. The if check has an and clause because we want both conditions to be met. The score should be greater than 50 and less than 60. If this condition is true, we look up the math scores for that particular individual using the square brackets and increment the value by 10 plus equal to 10. When we run this bit of code, you can see that Ram had a score of 55. His score has been incremented to 65. In this next problem, you'll get a chance once again to work with strings. We take as input a sentence which a user specifies. We want to count the number of vowels that are present in this sentence. A vowel is A, E, I, O, or U. Now, this program is very similar to the program that we wrote where we counted the number of E's that were input. The one difference here is we're interested in 5 different characters, A, E, I, O, and U. The way to make it easier to perform this check is to store this list of characters somewhere in a list or a tuple for quick lookup. Accept a sentence as input from the user. Store a list of vowels A, E, I, O, and U. These are characters in this list. Initialize a variable which stores the number of vowels that we encounter. This is the count vowels variable that is initialized to 0. We then iterate over every character in a sentence using the for in loop. We now need to check whether this character is a vowel. This can be done very easily by checking whether the character is in the vowels list. If yes, increment the count of vowels by 1 using the plus equal to. And once you're out of the for loop, you can print out the total number of vowels in the input sentence. Let's execute this program. We enter a sentence, how are you? And we get the result that the total number of vowels is 5, which is correct. If you observe, there is one thing that we haven't considered in this program. We haven't considered vowels that might be present as capital letters in uppercase. If you want your count of vowels to be case insensitive, there is one very small change that you need to make to this program. In your for loop, simply add the lower to sentence. Iterate over the sentence in lowercase, and then you're all set. Here is another programming problem that uses a dictionary. Accept user input. The user input will be in the form of a comma separated list of names. You want to extract individual names of students from this comma separated list, initialize a dictionary, and set the corresponding scores of all of these students to 0. And here is the hint in order to help you solve this problem statement. We are going to accept the user input in the form of a comma separated list of student names. In order to extract the names of individual students, you can use the string.split function and pass in the character on which you want to split the input. In our case, it will be the comma. Accept user input in the string format. This is a comma separated list of students or users. Now we generate a token list or the user list by splitting on the comma. This will give us a list of students. Once we have our student list or user list, as I've called it here, we can set up our dictionary. Initialize the dictionary first by setting the score dict to an empty dictionary. We then iterate over every user in our user list using the for in loop, and we initialize that user to a corresponding value of 0. The one thing that might be new for you here is that we call the strip function on the string. The strip function basically gets rid of empty spaces on either side of the string at the beginning as well as the end. Let's run this program. Here is our comma separated list of users: Amar, Vitthal, and Viren. And here is the dictionary that we've initialized. All of their scores are 0. Here is the next problem statement. You want to accept console input from the user. The user will type in names. You want to continue accepting names from the user so long as the user does not type exit. As soon as the user types exit, you'll stop accepting more names from that user. You want to store all of these names in a list. Here is the hint for this problem. We want to perform a set of actions where we accept names from the console input and then add those names to a list. We want to repeat the set of actions an unknown number of times. We have no idea when the user will actually type out exit and terminate our program. When we want to repeat a set of actions an unknown number of times, while loops are what we use. Let's first initialize the list to which we'll add the names. We'll call it the user list. It's first set to an empty list. We set up a while statement, which is just while true. The while true is needed because we want to execute this while loop an unknown number of times. The while loop will terminate only on the basis of the user's input, and we have no idea when the user will actually type out exit. So while true is what we'll use. We accept user input within this while loop. Every loop has to have a terminating condition, otherwise we'll end up with an infinite loop. Our terminating condition is when the user types in exit instead of any other name. If the user input is equal to exit, then we break out of this loop. If the user input is not exit and it's some other name, then we add that name to our user list. This last statement here will not be executed when the user types in exit, because when we break out of the loop, the remaining statements in the while loop are not executed. And really, that's it. Let's print out the list of users at the very end. Here is a user. We type in Amar, we hit enter. We type in Vitthal, hit enter once again. Let's enter one more user, Kishan, hit enter once again. Oba, again, we keep going through the loop over and over again till the user types exit. Once you encounter exit, we break out of the loop and print the names that we appended to our list: Amar, Vitthal, Kishan, and Oba.